In this video, we will have a look at the components of a wind turbine. First important components are blades. As you know that wind turbines convert the kinetic energy of wind into electrical energy. But in the first step, this kinetic energy is converted into mechanical energy, and then this mechanical energy goes into electrical energy. So blades are the large aerodynamically designed structure that capture the kinetic energy of the wind. Aerodynamically designed mean that most of the kinetic energy is captured and a very small amount of kinetic energy is wasted. The wind forces cause the blade to rotate, and the kinetic energy is converted into the mechanical energy. So when the wind is blowing on the rotor, it will cause this rotor to rotate. This rotating energy is a form of a mechanical energy. The rotational speed are typically 5 to 15 rpm, and usually these rotor are three-bladed. Why are they three-bladed? The reason you will see in another video, link is given in the description. The rotor hub. The rotor hub is the central structure to which the rotor blades are attached. So all of these rotor blades, 1, 2, 3, they are all connected to this central structure, which is called the rotor hub. The next component is the low speed shaft, also known as the main speed shaft. It transfers the rotational energy from the blades to the gearbox. So these blades are rotating, and with this shaft, which is directly connected to these blades, is also rotating, and it is rotating at the same speed as the rotor blades. Let's say this is rotating at 5 rpm, then your low speed shaft is also rotating at the 5 rpm. Next component is gearbox. Gearbox converts the relatively low rotational speed of the wind turbine rotor into a higher rotational speed necessary for generating electricity. So as we said, this is, let's say, rotating at 5 or 15 rpm. This shaft will also be rotating at 5 rpm. This is very small to produce electricity from a generator. So a gearbox is connected that increases the speed from 1000 to 1200 rpm. This component here is the gearbox. This will increase the rotating speed from 5 rpm or 15 rpm up to 1000 to 1200 rpm. It's important to note that some wind turbines may not have a gearbox. This you can see in another video titled Types of Gearbox, link given in the description. Next component is high speed shaft. So the output of the gearbox is connected to a high speed shaft. So this here gearbox, and then this is directly connected to a high speed shaft. This shaft rotates at a significantly higher speed than the low speed shaft. So let's say these blades are rotating at 5 rpm. Then this low speed shaft will be rotating also at 5 rpm. Then this gearbox will increase this rotational speed, and the main speed and the high speed shaft will be rotating at, that's at 1200 rpm. So this generator is rotating at the same speed as the high speed shaft is. And then at the end, this generator will basically generate the electricity. So what this generator does is that this generator converts the high speed rotational motion into the electricity. Also, this generator is connected to a low speed shaft, as we saw in the previous slide. Important, not always. There are some types of wind turbine where this generator could be directly connected to the low speed shaft, but that you can see in another video, and the link for that video is given in the description. Nacelle, component that houses the generator, low speed shaft, high speed shaft, and the gearbox, is known as the nacelle. So here you see this is the low speed shaft, this is gearbox, this is high speed shaft, and this is generator, and all of these are housed in one component. This component is known as the nacelle. Similarly, if you look here, this is closed, and you cannot see the components inside. This is also the nacelle of a wind turbine. Anemometer, it measures the wind speed, because in wind turbine we need a lot of parameters, and most important parameters include wind speed. So these are mounted right on top of the nacelle. You can see this is the nacelle, and there is an anemometer measure placed to measure the speed of the wind. Next component is the tower. A tower are the tall structure that support the entire wind turbine assembly. So as you can see that we need to mount this wind turbine at a certain height from the ground, because here the wind conditions, let's say if we mount it here, the wind conditions are not appropriate to generate enough speed. So we mount it where wind conditions are better. This structure needs to be very strong, and the material is usually steel, could be concrete or hybrid. And the reason for this structure to be strong is that it has to carry the weight of the rotor, nacelle, generator, gearbox, and all of the other components could be very heavy. That's all for today. For the part 2, there are some other components of the wind turbine given. Thank you for watching.